Great, we're going to continue in this section, alright, with factorization by grouping. Alright, so in this method, we are normally given 4 algebraic terms, as we could see here. Alright, and we first group the terms into pairs. So what we're going to do is we're going to group the terms into pairs, and then we are going to factorize. Okay, so let's look at the first pair. What term is common in the first pair? We can see there that A is common in the first pair, so we are going to factorize out A. Let's take a look at the second pair. What is common in the second pair? We have bx plus by. We can see that we have b is common. Alright, so let's do it again. We're going to look at it, we're going to group these 4 terms into pairs. Great. What's common in our first pair? A is common, so we're going to factorize out A, and whatever we factorize, we're going to put on the outside. And then we're going to put what remains in brackets. That's how we factorize by grouping, okay? Let's continue. What else is common in the first? What is common in the first, not the first, but second pair? B. Excellent. So we take out B, and in brackets we are going to put what remains. What remains? X plus y. Good. And to end this factorization by grouping, we're going to take the terms that remain on the outside, we're going to put it in brackets as you see here, and then we have x plus y in brackets twice. We're going to write it in a bracket outside once. This is our final answer. Let's do another one. Let's look at 2ax. Alright, minus 6ay plus bx minus 3by. Again, we're going to factorize it in pairs. And if we realize that it is in pairs, but there isn't any common terms, we can always arrange it. Okay, so let's go. What could we factorize in the first pair? Let's check the numbers. We can factorize out 2, because 2 can go into 2, 1, and 2 can go into 6, 3. So the number we factorized out was 2. 2 comes on the outside. What goes on? Anything else to factorize? Yes. We could see we have 2 common A's, 2 common terms. So we scratch it off and we put it on the outside. Now we're going to put what remain in brackets. What remain? X minus 3y is what remains. Plus, let's look at the next pair. What could we factorize here? B. Yes, we can see that B is common. So we put B on the outside. Is there any common terms? No more. So we're going to put what remains on the inside. What remains? X minus 3y is what remains. What is going to be our final line? The terms on the outside we are going to put in brackets 2a plus b, and then the term on the inside of the bracket. So 2a plus b, close bracket, plus x minus 3y. Alright, and this is how we factorize by grouping. I'm going to do it again. Alright, I'm going to do it again from the top. So again, we are factorizing by grouping. Okay, and when we're doing this method, we're going to group into pairs. Okay, so we have ax plus ay. They are common terms there, so we can factorize that pair. Let's look at the second pair. We have bx plus by, so we know that there are common terms in that pair for us to factorize. In the first pair, we see that the a is common. We take the a, we put it outside. Alright, what else? Nothing else is common, so we put what remains in brackets. Let's move on to the second pair. What is common in our second pair? B is common, so we factorize out B. We put the b on the outside. Are there any more common terms? No. So what we do, we're going to put the remaining terms on the inside. When we are finished doing this, we're going to factorize once again. What are we seeing are the common terms here? Right, we're going to put, yes, the outside terms a plus b in brackets, but we could also factorize out the bracket x plus y. Okay, it's common, so we can further factorize it once again. Alright, that's how it's going to be. Let's look at another example. We have 2ax minus 6ay plus bx minus 3by. We're going to factorize the first pair, and then we are going to factorize the second pair. The question is, what is common in the first pair? Let's look at the numbers first. We can see that 2 can go into 6, so we could factorize out 2. Alright, so let's do that. We're going to say 2 into 2, 1. And we're going to say 2 into 6 is 3. Let's begin. 2 into 2, 1, and 2 into 6 is 3. What do we put outside? 2. We factorized out 2. Are there any more common terms? Yes. A. Right? We have A. A is common. We're going to factorize it and put it on the outside. Do we have any more common terms? No. So we're going to put the remaining terms in brackets. So we have x minus 3y goes into bracket. After we are finished doing this, we are going to factorize the other pair. What are the common terms? B. We're going to factorize the b and put it on the outside. What are our remaining terms? X minus 3y. Once we are finished with this step, we can further factorize. As we can see once again that we have two common terms. So we're going to factorize out that bracket as well as put the outside terms in brackets. So our final line will look like this: 2a plus b in bracket plus, plus b in brackets, open brackets, x minus 3y in brackets. So this is how our final line looks like. Let's do another example. We have 4pr plus 3qr minus 4ps minus 3qs. Again, we're going to factorize in grouping. We're going to factorize in pair. Let's look at the first pair. What are common? The 4 and the 3 no. The p and the q no. The r. So we could factorize out the r. Good. Once we factorize out the r, it goes on the outside. There is nothing else to factorize in the first pair, so we're going to put the remaining terms in brackets. So we have 4p plus 3q, and that's going to come in brackets. Let's go to the second pair. What is common? The 4 and the 3 no, the p and the q no, s and s. So I'm going to factorize out the s, and the s is going to come outside. What remains? Again, 4p minus 3q remain. After this, we can further factorize. Okay, we're going to put the outside terms in brackets, that is r minus s. Okay, and we can further factorize the brackets. As we can see there, we have two common terms, so we're going to take out one. So you're going to put 4p plus 3q in brackets. Okay, let's go to the next example. As you could see in this example, factorization was already done. Right? Look at the second line in the first example there. Good? They gave it to us in the second step. So we don't have to factorize it twice, we're factorizing once. So the outside terms is 5ml minus 3pq. And as you can see in brackets, there are two common terms. We're just writing it back once. Okay? I'm going to show you this step again. As we can see in this step, okay, as we can see on as we can see here, factorization was already done. Look at the second example on the screen. Alright, so as we can see here, we're going to put the outside terms in brackets, and then we're going to factorize out the bracket that is common. Alright, usually we'll have to factorize to get to this second line, but they gave us from the second line and they want us to factorize. So in other words, it was less work for us. So all we did was group the terms on the outside in brackets, and we factorize out the common bracket. So 7x minus 5 is going to come in the bracket to complete the sum. Right, so now we're going to move on to adding and subtraction of algebraic fractions. As we know, when we are adding and subtracting fractions, it is important that we always have common denominators. And if we do not have common denominators, then it is important for us to find the LCM. What is the LCM? The lowest common multiple. Alright, what is the lowest common multiple of 3, 5, and 10? What number could 3 go into 5 going 2, and 10 going 2. Alright, so that's the step we're going to do here. We're going to find the LCM. Now if I don't know what the LCM is, it's safe to go to my working column. I am creating here LCM working column for us. Okay, and this is how we can find the LCM. If you can't, look at the denominators and figure it out offhand. So I'm putting my denominators here, 3, 5, and 10. What number can go into 3, 5, and 10? 3 can go into 3, so I'll start with 3. 3 can go into 3, 1. Could 3 go into 5 without a remainder? No. So I just bring down my 5. Could 3 go into 10 without a remainder? No. So I simply bring down my 10. Now what could go into 5? 5. Okay, so I'm going to bring down my 1. And let's continue. 5 into 5 is 1. And 5 could go into 10 how many times? 2. Now what can go into 2? 2. So I'm going to bring down my 1s here again until I get to my 2, and I'm going to say 2 into 2 is 1. Good. And this is the end of it. To get the LCM, all we do is multiply the numbers we remained with on the outside. So we remain with 3, 5 by 2. So 3 5s are 15, and 15 by 2 is 30. So our LCM for this sum is 30. 30. I'm writing that. The next thing I am going to do is divide and then multiply. Yes, I'm going to divide my denominators and I'm going to multiply my numerators. Okay, so let's begin. I'm going to say 3 into 30 is, I'm writing the word into because this is what I say. Okay, good. I'm going to say 3 into 30 is 10. And 10 multiplied by whatever my numerator is. I'm not going to multiply my numerator. I'm simply writing everything down. Okay, I'll multiply after. So 10 multiplied by x. As you can see, I'm using my brackets interchangeably. Alright, of a multiplication sign. If I had a multiplication sign, it would have been the same thing. So let's go on to the next part. 5 can go into 30. 6 is going to be 6 by whatever my numerator is. 6 by x. Plus 10 into 30 is 3, and it's going to be 3 by whatever my numerator is, right, which is going to be 3 by x. Good. What we're going to do now, we are going to multiply, right, out our brackets. Good. So 10 by x will give us a total of 10x, plus 6 by x will give us 6x, plus 3 by x will give us 3x all over 30. And as we know in algebra, we can add and subtract like terms. Alright, so because we have all x terms at the top in our numerator, we can add them. So 10x plus 6x plus 3x is going to give us a total of 19x over 30. And this is how we solve this. Now, we're going to move on to another example. Right, so in this example, you're not seeing it too clearly, but we have 3x plus 4 over 3x minus 5 over 4x. Let me say it again. In this example, what you're not seeing there is a 3. So we have 3 over x, you can write it, plus 4 over 3x minus 5 over 4x. And what are we going to do here? Okay, we are going to find the LCM. The question is, what is the LCM of x, 3x, and 4, 3x? Okay, so we can go to our LCM column and we can work out the LCM of what is understood in front of our x1. Okay, so we're going to find the LCM of 1, 3, and 4. Okay, so I'm going to bring down that 1. What can go into 3? 3. So 3 into 3 is 1. Could 3 go into 4 without a remainder? No. I'm going to bring down my 4. Alright, what can go into 4? 4. So I'm going to write 4 there. Alright, I can use 2. Okay, I'm going to say 2 into 4 is 2. And I have to use 2 again. Alright, so 2 into 2 is 1. Now to get our LCM, all we do is multiply the numbers that will remain with on the outside. So we're going to multiply 3 times 2 times 2. And 3 2s are 6, and 6 2s are 12. Alright, so 12 is our LCM. Okay, and what we're going to say now, we're going to say 1 into 12 is 12. Yes, I'm going to divide my denominator and I'm going to multiply by my numerator. So I'm going to say 1 into 12 is 12. So 12 by 3 is going to give me, I'm not working it out, I'm going to write it. I will work it out after. So 12 by 3 plus 3 can go into 12 how many times? 4 times. So it's going to be 4 by whatever my numerator is, and my numerator is 4. So I'm going to write that 4 multiplied by 4 minus 4 into 12 is 3, and 3 multiplied by 5. So I'm going to write 3 multiplied by whatever my numerator is, and my numerator in this case is 5. Alright, so what can I do now? Work out my numerators, work out my brackets, right? Good. One of the reasons why I keep saying you are multiplying, okay, the number you get by whatever your numerator is because your numerator could sometimes be something like this. So let's say in this example, if you didn't have, right, let's say for example, if you didn't have your numerator as 5, but in this example your numerator was 5x squared minus 3y, then when we say 4 into 12 is 3, it would be 3 multiplied by whatever our numerator is. So let's say our numerator was 5x squared minus 3y, then it will be 3 multiplied by this entire bracket here, 5x squared minus 3y. Good, I'm just showing you this because your numerator doesn't have to be one number. Your numerator could be a lot of numbers, like in this case. Alright, so that's why I'm saying you write it down and you work it out in parts. Now I could look at 3 and say 3 5s are 15 and work it one time, but I'm doing it in parts so that you will be able to see, if you get a lengthy numerator, what you can do to get the answer. Alright, so let's move on back to the question. Now we're going to work out our brackets. So we have 12 threes is going to give us 36 plus 4 fours are going to give us 16. As you can see, I'm fighting for space here. Minus 3 fives are 15. So it's minus 15. And it's all over our numerator, which is 12x. Sorry, our denominator, which is 12x. Okay, so as you can see, we have numbers in our numerators and we can work them out. So we can say 36 plus 16 minus 15 is going to give us 37 over 12x. Okay, excellent. Good. In this next example, we're going to have to find the LCM. You will see the sum shortly. We're going to have to find the LCM of 9 and 18. Alright, so as you can see here, I created a LCM column. Alright, so we're going to work out the LCM first of 9 and 18. I'm sorry you're not seeing the sum at the moment, but you will see it shortly. Okay, so we're going to first find the LCM of 9 and 18. Okay, again I'm showing you step by step here. How do I find what is the LCM of 9 and 18 in this new sum? Good, 9 can go into 9 one time and 9 can go into 18, yes, 2 times. Now 2 can go into 2 one time. So to get the LCM, we multiply the numbers on the outside, so 9 2s are 18. So the LCM of 9 and 18 is 18. Let's get to the other part of the sum. In this sum, I'm sorry you're not seeing it at the moment, but you will shortly. In this sum, let me go to forward. This is the sum. Alright, the sum that we are working out now is 7 over 9pq plus 5 over 18pq. Alright, so we have 9pq and 18pq as our denominators. And what we need to find here is the LCM. Again, before we add or subtract fractions, we must ensure that we have common denominators. And if we do not have common denominators, what we do is we find the LCM. And that is the part you just saw me doing, the LCM. I found the LCM of 9 and 18. Now, this is algebra, and as you can see here in our denominators, we have P and Q. Alright, so it is also going to be included in our denominator of the LCM. So the LCM is P, 18, P, Q. So the first question we're going to ask ourselves is 9 into 18 is going to give us what? 2. Right, so it's going to be 2 multiplied by whatever our numerator is. It's going to be 2 multiplied by 7. Okay, plus we have 18p. This one's a little tricky. Let's look at it. We have 18p into 18pq. Now let's pause there. I have 18p into 18pq. I don't have 18pq into 18pq, which will give me 1. I have 18p into 18pq. So let's go to our division column. Let's work this out step by step so that you will see how I am going to get my answer. So I have 18pq over I have 9 there, but it's supposed to be 18 actually. It's supposed to be 18. Let me check back. Is it 18 or 9? Yeah, it's supposed to be 18. It's supposed to be 18 into 18. So that's an error there. Alright, so let's go back to the working column. So I have 18 into 18 would be 1. P can cancel off P. And this Q can cancel off. Oh, this was the first part that it's working just now. Let's wait a bit for the second part. Alright, I'll definitely have to do another video on this topic. Right, so this is the part I want to get to. 18pq divided by 18p. How am I going to work this? 18 into 18, 1, and 18 can go into 18, 1. This p can cancel off this p, but what do I remain with? My numerator, I remain with q. Okay, so if I come back on the side, I remain with q. I now have to multiply q by whatever my numerator is. Okay, let's take a look. 18p into 18pq would be, we will remain with what? Q after we have finished dividing. So I am going to multiply q by 5. I'm just writing my number first by q. So this is my numerator. Alright, so now I'm going to multiply my numerators. 2 7s are going to give me 14 plus 5 by q is going to give me 5q all over 18pq. There is nothing more I can do to this sum because I have 14 plus 5q. And I cannot add terms that are not similar. If I had a q at the 14, I could have added. But I have 14 plus 5q, so I cannot add that. So that's the end of this question. Alright, so we're going to move on to another. And I hope as I continue to explain that you're understanding it better and better. So let's look at this question. I have 3 open brackets x plus 4 all over 7 minus 4 multiplied by x plus 1 over 5. Again, I am subtracting this fraction. So what do I have to do? I have to ensure that I have common denominators. And if I don't have common denominators, then I must find the LCM. So here in this fraction, my denominators are 7 and 5. So I'm going to find the LCM of 7 and 5. 7 can go into 7, 1, but 7 cannot go into 5, so I'm bringing down my 5. Then I'm going to use 5. I'm bringing down my 1 there, and then I'm going to say 5 into 5 is 1. Alright, then I multiply my numbers on the outside, which will give me my LCM. And 7 by 5 is 35. So the LCM for this sum is 35. Now I'm going to do what I'm accustomed doing. I'm going to divide my denominators, and then I'm going to multiply it by my numerators. Alright, so the first thing I'm going to say, 7 into 35 is 5. So 5 multiplied by whatever my numerator is. And you can see my numerator is a whole, is 3, open brackets, x plus 4. Okay, so I'm going to write that. 5 multiplied by 3. 5 multiplied by everything here. Right, on the next side it's going to be the same thing. 5 into 35 is 7. It's going to be 7 multiplied by everything here. Alright, so what I'm going to do, I'm going to begin to multiply. I'm going to say 5 3s are 15, and I'm going to write 15 multiplied by everything in the bracket. Alright, I work the outside. 5 3s are 15 multiplied by everything in my bracket. X plus 4, close bracket, minus 7 4s are 28 multiplied by everything in my bracket, which is x plus 1. I hope you see how I'm doing it in parts and I'm not rushing it. Okay, now I'm going to work out my brackets. 15 by x will give me a total of 15x, plus 15 by 4 will give me 60. Alright, minus 28 by x will give me minus 28x, minus by a plus, I have minus 28 by 1 is going to give me minus 28. Okay, and there we have our numerator all over 35. Now as you can see, my numerator, I have x terms and numbers. So I'm going to group my x terms together and add them or subtract them. And then I'm going to group my numbers together and add them or subtract them. So I have a total of 15x. Are we seeing it? 15x. What is the next x term? Minus 28x. Alright, so I'm going to write it. 15x minus 28x. Then my numbers, I have what? Plus 60 minus 28. Alright, all over 35. So I'm going to work out my x terms. I have 15x minus 28x. This will give me a total of how much? Negative how much? What's my total x? 15x minus 28x is going to give me a total of minus 13x. Right? Plus, I have 60 minus 28. It is going to give me a total of how much? Yes, you're in maths class, and I really hope you're not listening to me alone calculate. I alone calculate. I hope you're calculating as well. Alright? Good. So again, we have 60 minus 28 is going to give us a total of 32. Alright? So that is going to be our answer. Again, I'm not too sure why this screen shifted. Alright, but we're going to move on. We're going to move on. Again, I promise to do another video on this. So the final answer is negative 13x plus 32 over 35. Okay? And that's it. We cannot minus the x term from the number. So it's going to remain like this. Alright, finally. Okay. We're going to move on. We're going to move on to multiplying and dividing algebraic fractions. So before we was adding and subtracting them, and in those cases we had to find the LCM, and now we are going to multiply and divide them. Alright, good. So let's begin with our first question. We have p cubed x over qr. That's supposed to be a division. Mark there, not a plus sign. I'll change it. Division. Alright, so it's going to be p cubed, p to the power of 3x divided by qr divided by py over q squared r. How am I going to divide this term? Now, usually when we're doing fractions and we have a division sign, the first thing we do is write over the first fraction, which is p to the power of 3x over qr. I'm going to change my division sign to a multiplication sign, and then I'm going to flip my next fraction or find the reciprocal of the next fraction. So if I flipped the next fraction, I'm going to get q to the power of 2r over py. Okay, this is what I do. I change my division sign to a multiplication sign, and then I find the reciprocal of the following fraction. Alright, so what I'm going to do now, I'm going to group them into one. I'm going to make them, multiply them and make them one fraction. So I'm going to write p. It's going to be easier for me to work like this. So follow this technique, write this down. P to the power of 3x multiplied by q squared r all over, I'm making it one fraction, qr multiplied by py. Now, after I've finished doing this, writing it as one fraction, what I'm going to do, I'm going to simplify. I'm going to simplify each term like this. What is p to the power of 3? P to the power of 3 is simply p multiplied by p multiplied by p multiplied by x multiplied by, what is q to the power of 3? Q 3 times q multiplied by q multiplied by q multiplied by r all over, what is qr? Q multiplied by r will give us qr. So you see, I'm separating each term. What is going to give me? Py. P multiplied by y. When I do this, it's easier for me to divide. Alright, so this p could cancel off a p up here. This q could cancel off one of the q up here. This, do I have any y? No. This r could cancel off this r. So what do I remain with? How many p's? 2 p's. So it's going to be p to the power of, because p by p is p squared. P multiplied by p will be p to the power of 2. Alright, so p multiplied by p will give me p to the power of 2. What else do I remain with? X. Alright, I remain with x multiplied by q multiplied by q will be q squared. Alright, are we seeing that? Oh, I made an error. Instead of q to the power of 3 here, right, this is supposed to be q to the power of 2. So there's an error here. Work with me. I'm going to change it. Alright, so instead of q to the power of 3 here, it's supposed to be q to the power of 2. Alright. Yes, it's supposed to be, let's write it properly. It's supposed to be q to the power of 2. Which means that I have an extra q here that I have to erase. Okay, so let's erase this extra q. So I'm not remaining with q squared, I'm simply remaining with 1q there. Are we seeing that? Yeah. Alright, so what do I remain with? I remain with p to the power of 2, p twice, multiply by x multiplied by q, or qx. This is what I remain with. What do I remain with in my denominator? I remain with a y. No, xy actually. So I'm going to remain with xy, so I'm simply going to write it over xy. It's really simple. Just take your time, separate each term, and then divide. Right? And again, once you have a division sign, you have to change your division sign to a multiplication sign and then find the reciprocal of the other fraction. Let's look at this example. We have 3ab over 7rs plus 6a to the power of 3 over 7r squared. Now, this is not supposed to be a addition sign. Again, we're doing multiplication and division, so it's a division sign. Okay, we're going to divide these two. How am I going to do that? I'm going to write over the fraction 3ab all over 7RS. I'm changing my division sign to a multiplication sign. Then I'm going to flip the next fraction, or what we say, find the reciprocal of the next fraction. Okay, if I flip the next fraction, 7R squared will be at the top and 6a to the power of 3 will be underneath. What I'm going to do, and I'm going to group, I'm going to multiply my fractions to make it 1. So I'm going to multiply the 3ab multiply by the 7r squared all over, yes, I'm just making it one fraction here, 7rs multiplied by 6a cubed. What am I going to do now? I'm going to separate each term. What is giving me 3ab? 3 multiplied by a multiplied by b. What is giving me 7r squared? 7 multiplied by r multiplied by r. I'm separating each term. Okay? All divided by 7rs. What is 7rs? 7 multiplied by r multiplied by s. All these terms are multiplied to each other. Alright? So it's going to be 7 multiplied by r multiplied by s multiplied by b, not b, 6 multiplied by, what is a to the power of 3? A multiplied by a multiplied by a. Alright? A multiplied by a, yes. Multiplied by a multiplied by a. Good. Now we can look to see what can we cancel off, what can we divide. Let's begin with a. This a can cancel off this a. Do I have any more a's? Nope. Do I have r's? Good. That r can cancel off that r. Good. That 7 can cancel off that 7. Any more things to cancel off? Yeah, I'm seeing a 3 and a 6. I can say 3 into 3. Yes, I can go with the numbers now. I can say 3 into 3, 1, and 3 can go into 6 2 times. Good, so everything looks reduced there. Yeah? So what do I remain with on top? In my numerator, I remain with b, r. That's it. What do I remain with as my denominator? I remain with s, 2. Right? I remain with 2, so I'll write it like this. 2a squared s. Alright, as you can see, I have 2 a's there. So I'm going to write it like this. So I remain with 2, I remain with an s, and I remain with 2 a's. A by a will give me a squared. I did not say a plus a, because a plus a will give me 2a. But a multiplied by a will give me a squared. Let's look at yet another example. I have a squared over b squared by c to the power of 3, or c cubed, multiplied by b cubed, or b to the power of 3c squared over a. I have to multiply this. How am I going to multiply this sum? Okay, as we were doing before, when we were multiplying, what did we do? We made it one fraction. So I multiplied everything together, a squared by b cubed, c squared all over b squared. Just gonna write this better. B squared c, and listening to me work this as opposed to you writing while I'm writing and working it out is different. Maths is not one to watch, but write and work it out. B squared multiplied by c cubed multiplied by a. So what I did, I made it one fraction, and then I'm going to separate each term. A squared is a multiplied by a multiplied by, what is b to the power of 3? B multiplied by b multiplied by b. What is c squared, or c to the power of 2? C multiplied by c. All over, what is b squared? B multiplied by b. What is c to the power of 3? C multiplied by c multiply by c. Multiply by a. Now let's see what terms we can cancel off. Alright, as you can see, this b can cancel off this b, this b can cancel off this b, this c can cancel off this c, this c can cancel off this c, but this a can cancel off this a. So what do I remain with as my numerator? I remain with ab. Yeah, as we can see here, the terms on top, what do I remain with? AB over, what do I remain with as my denominator? I'm only seeing a c. Yeah? Are you seeing that? So the answer is going to be AB over c. And this is how we multiply and divide algebraic fractions. So we looked at adding and subtracting them, alright, where we had to find the LCM, and then we looked at multiplying and dividing them. Alright, and this is the end of the first part of the video that got cut off, alright, that I did before. Okay, excellent. Look out for the next video that I'm going to be doing on equations. Alright, so this is the end of this part.